Yes, everybody, it is hip to be square. Alright, it's just a song we usually sing or play when we talk about square roots, which is what your notes are over today. So, we are going to work through your notes pretty quick. This is probably, I'm guessing, less than 5 minutes, maybe 6. So we're going to just fly through this, and you're going to have this done and be working on this in class. So, when we talk about square roots, if you look at your notes here, definition of a square root. Well, the square root of a number is a value that when you multiply it by itself gives you the number. For example, the square root of 49 is 7. Okay, so square root is what you would take a number, and if you squared it, you'd get the other, just back and forth. So square root of 49 is 7. 7 squared is 49. A perfect square. Well, there's a list of them right here on your left. Most of them you know, and there are some extra that you may not know or may sort of recognize, but they're there for you in case you ever need them. And again, a perfect square is a number that is a square root that is a whole number. So again, look to your left. These are the ones you know, and a few more. So again, whole numbers. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3, and so on. We're going to work with estimating square roots. And that is finding out the square root of a number that's not a perfect square, because the square root of 1, yeah, we know that's 1. We know the square root of 4 is 2, but what about the square root of 2 or the square root of 3? Those are those numbers that aren't perfect squares, and we have to be able to estimate those answers. You can't really get the exact answer without the calculator, but you can get pretty close. So we're just going to do a couple quick examples. So let's say we had to find the square root of 18. Well, we don't know the square root of 18 by heart. It's a irrational number. It's a decimal that goes on forever. But our knowledge of some of the perfect squares can help us get pretty close to that answer. So the fact that we know the square root of 16 is 4 and the square root of 25 is 5, well, we can make a decent estimate at what the square root of 18 would be. We should know that it's got to be somewhere between 4 and 5. And what we write here is we write these little squiggly equal signs, and that just means you're making an estimate at this. Now, by looking at this, we see that 18 is a lot closer to 16 than it is to 25. You're never going to have one right in the middle when you're dealing with whole numbers like this. So we're going to guess that this is about 4.2, just because it's a lot closer to 16 than 18. If you really wanted to get technical with it, you could look and see that to get from 16 to 25 is 9, right? To go from 16 to 25 would be 9, but we're only going 2 up from that. So if you wanted to make an even closer guess, if you wanted to estimate that it was, again, since you went up 9, and it's only 2 away, if that makes sense to you, 16 to 18 is only 2, 16 to 25 is 9, so you only went 2/9 of the way from there, and that would give us, again, 4 and 2/9 is this, so that we can see that our estimate is pretty close. The reason we want to have good estimates is because when we have to work with these, usually it's with measurement, and we want to get as close to the answer as we can, and that's what we're going to practice here. So let's do another one. This we're going to do the square root of 90. Now again, we don't know the square root of 90 by heart, but you should know the one above it, or lower than it, even though we write it above it, is 81. And then the one below it is 100. Okay, so we know it's got to be somewhere between 9 and 10. So we're going to estimate. If you look, it's to get from 81 to 90 is 9 away, and to get from 90 to 100 is 10 away. Now, it's a little closer to 9 than it is to 10. So if you said 9.4, or even if you actually put 9.5, because it's pretty close, that would be a good estimate. You wouldn't want to put 9.2. That's not, it's close to the middle, so we want to make sure that our estimates are actually close to the real number. And if you want to put these in the calculator to see what you get, you probably would get really, really close to what we're estimating. All right, one more example. We're going to do the square root of 196. Okay, again, that's not one, I'm sorry. We're going to do the square root of 200. So I'm going to do it like this. The square root of 200 is what we're trying to find. The one below it is 196, which you might have to look over here to find. It's 14. Okay. And the square root of 225 is 15. So, I know it's got to be in between 14 and 15, and if we look, it's only 4 away from here. So to get from 96 to 200 is only 4 away. And to get from 200 to 225, well, that's a long way away, okay? So it's really, really close to 14. If you wanted to estimate this as about 14.1, that would be a really, really close, good estimate of that, okay? All right, now, question, why would you need to do this? Well, the first thing we're going to use this in is when we do the Pythagorean theorem here in a few days. So the Pythagorean theorem, you've seen that before. You remember it from 7th grade. Or if you're a 7th grader, you may have seen it, and you're going to see it again this year. But that's a squared plus b squared equals c squared. We use it with right triangles, okay, where we got a, b, and c. And we'll need to be able to do this to estimate square roots to find the actual answer. So, or as close to as we can to the answers. The second thing you'll have to use it is for length of a side of a square. Okay, so we got 2 examples down here. If they said to you, if you had a question asked and said, hey, the area of this square is 40, how long is each side? Well, it's a square and the numbers have to be the same. So what they're really asking you to find is the square root of 40. Okay, we don't ever divide by 2 to find square root. That never works. But we can estimate that the square root of 40 has got to be somewhere between 6 and 7. And it's a lot closer to 6 than it is to 7, because 40 is close to 36. It's only 4 away, but it's 9 away from this one. So we could probably estimate this is about 6.2, maybe 6.3. That would be close enough. If you were taking a test with multiple choice answers, you'd see that there was only one of them that was really close. Okay, and this last one, just to finish off our notes, if they said the area of the square was 108, and you had to find the length of each side, again, it's a square, both sides have to be the same number, so we're going to estimate. And if we have to look at our chart, then we do that, but we know the one that's lower than it is 10, the square root of 100 is 10, and we should know the next one, 11. So again, we're going to try and find the number that's right, as close to this as we can. Now, this one's closer to the middle, but about 110, 111 would be the middle. So if we estimated this isn't quite the middle, it's a little bit lower than the middle, that's a pretty good estimate, 10.4. If we multiplied that times itself, we'd get a pretty close answer. So this is square roots. We'll be using this a lot pretty soon, Pythagorean theorem. And again, length of a side of a square. And that is it for the notes. So you're all set to go, and we'll see you soon.